Hello, this is Dmitry, and this will be my second video about the alkaline battery testing of different brands. Today we have two sorts of batteries from Lexman. This is a brand of Leroy Merlin. Here we have standard ones and intensive ones. In previous video I tested Carrefour batteries and get pretty interesting results actually, so let's take a look what do we have with the Lexman. Test setup exactly the same as it was before. Here we have ASUS Tinkerboard, it acts as data collector. Here we have ESP32, it's just used as ADC to UART bridge. And here we have IMAX, that will be discharger for these batteries. And let's get started. Let's install standard one and start discharging. Okay, Lexman standard is installed. By the way, there is no way to open this box gracefully, as you can see, only with vandalism from the front end. And here we have something, but I don't found that opening way in this pack. Okay, so as usually I will discharge these batteries with 0.1, 0.2 and 0.5 amperes, and after 0.2 and 0.5 I will let them to, let's say, cool down a little for 12 hours or more, and then I will discharge them again with 0.1 ampere current to check how much capacity is remained after initial discharge. Actually, on big currents there may be more capacity remain than in that it was delivered at first charge. This means at first discharge. Sorry, this means that if we observe picture like that, this batteries is not suitable for high currents, so they only good for low currents. With Carrefour, we have more capacity remain than available at 0.5 amperes. So Carrefour batteries, it's definitely not good for high currents. Let's check this Lexman. Let's start with 0.1. Okay, and here we go. It was a small mistake. I turned on charge mode instead of discharge, but right now I noticed it and switched it to discharge. It refused to charge it, so no additional charge applied, and results will be correct. Right now we have discharging process, capacity is counting and voltage slowly dropping. All good for now. Here we go, 0.1 ampere current discharge finished, and we got a decent amount of capacity of 2000 and almost 200 milliamp hours. It's not too bad, not fantastic, but not too bad for cheap AA alkaline. Let's try to discharge it with 0.2. Let me change the battery and reset the data logger. Okay, here we go. New battery is installed and data logger is reset. Let's check what we will have with 0.2 amps. And by the way, in this video I will not make diagrams for each discharge. Instead, I will just make one set of summary diagrams after we will finish tests of these standard alkalines and these intensive ones. So let's test standard with 0.2 amperes. Okay, here we go. And 0.2 amp discharge finished. As you can see, capacity is almost 400 milliamps less than it was with 0.1. It's a significant drop, but capacity is, I guess, still okay, still not too small for cheap alkaline. And let's perform test with 0.5 amps for Lexman standard. Let me replace the battery and reset the setup. Okay, it's all done, and let's perform last discharge for Lexman standard 0.5 amps. Here we go. And as you can see, at the very start, at the very beginning, voltage drops for almost 1 volt almost immediately. It's a crazy voltage drop, but let's take a look what capacity we will have and what voltage graphs we will have. 0.5 amps discharge is finished, and as you can see, capacity is dropped well below than half of initial capacity at 0.1 amps. So I guess Lexman standard is also not good for high loads. Let's check Lexman intensive. Let me change the battery. One moment. Okay, we're ready to start discharge test for Lexman intensive 0.1 amp. Let's go. Let's take a look if there is some difference between these two, or maybe they are more or less same, just in different package and different price. Let's see. Discharge started. Let's wait for results. 0.1 amp discharge is finished for Lexman intensive, and as you can see, capacity is almost the same like it was with Lexman standard. I don't remember exact numbers, but it's not exact, but about the same. So interesting. Let's take a look what do we will have with 0.2 amp. Okay, we are ready. Battery is changed and logger is reset. So let's take a look what do we have with 0.2 amp. Okay, it's going. 0.2 amps discharge is finished for Lexman intensive, and as you can see, capacity is a bit lower than it was with standard Carrefour with 0.2 amps. So it's strange, because at intensive we can see that it should perform better in high drain devices, while in standard we have low drain devices printed here. But actually at 0.2 amps standard performs better than intensive. Not too much, but capacity from standard was a bit more. Okay, let's install new intensive battery and check what we will have at 0.5 amps. Okay, I'll set to perform 0.5 amp test for Lexman intensive. Let's start it. Okay, it goes, and oh, voltage drop under 1 volt immediately after starting the test. So it seems like things go really bad here. Capacity is important factor, but maybe intensive battery has higher voltage on discharge curve. So it's too early to make some decisions here now. But for now, it looks like intensive battery works a little worse than standard, which is counterintuitive. But okay, let's perform last test and take a look on the graphs. And 0.5 ampere discharge is finished for Lexman intensive. And we can see that capacity for intensive is almost 25% lower than for standard in 0.5 ampere scenario, which seems really strange. As you can see, I hope you can, they clearly not expired, so they not too old, they was new when I bought them. They was from Leroy Merlin store, so it should be original ones, but for some reason intensive batteries has really lower capacity at high current than standard ones. I will prepare diagrams so we can compare and see what happens, but for now, for this raw data, we can see that intensive is not so intensive. It's completely counterintuitive, and as you can see here, it's for high drain devices. This one is for low drain devices, but for some reason intensive works worse than standard. So finally our test is finished for Lexman intensive and standard batteries, and here you can see the graphs. You can see two graphs, yellow and blue for 0.1 amp, red and green for 0.2 amps, and here light blue and orange for 0.5 amps. And can you guess which one is for which battery? Where is intensive and where is standard? There is almost no difference. So here you can see a legend, and actually blue one is intensive, blue one is diet a little faster, yellow is standard. Standard work a bit longer, not too much, but a bit longer. Here green one is standard. So as you can see, standard works a bit longer, not too much again, maybe 1 or 2%, but longer. So if you will choose between standard and intensive, just buy cheapest one. There are almost no difference between them, which is really strange, because standard is positioned as a battery for high drain devices, while intensive is for high drain devices, and standard one is for remote controls, clocks, and so on. But actually, there are the same, which is really strange. Please let me know in the comments. Do you have any ideas what to test next? Maybe you want to see some brands or other test methodologies. What do you think about this all? Please let me know. Thank you for watching. Bye.